Okay, today we go to chapter 6, general motion in the straight line. So, this chapter we will consider the straight line motion only, and we at the chapter 1, you still remember that we always use the constant acceleration equation to calculate the v, for example, s, okay, and there are few formulas that in your formula booklets. Do remember that for example v equal to u plus at. For this formula we always consider the a is constant, right? And similarly v square equal to u square plus 2as. So the a is constant also. So in this chapter we will consider when the acceleration is not constant, right? So when the acceleration is not constant, right, so normally the question will give you an equation, okay, an equation to represent, okay, the a or any others v. Okay, so this is similar to your if you have learned in paper 3, this is similar to the chapter of parametric uh, equation, right? So if you not learn in the paper 3, no issue. Okay, I think this chapter only go through a very simple integration and differentiation only, right? Okay, so we will move to the equation that have a changing of the acceleration. Right. Okay, so the first differential equation that we have is v equal to ds dt. Right, the velocity is equal to the changing of the displacement over the changing of the t. Right. So this relationship actually v equal to ds dt, just do the differentiation if you're given v s in terms of t or anything, so that when you differentiate, okay, you can directly get the v. So from this general equation that you know, v is equal to the slope of the graph s versus t, right? So from this you know that the changing of displacement according to the t is equal to the v. A very simple equation, right? So we go for question 1. Okay, for question 1, a particle move in a straight line so that its displacement s meter at time t is given by s equal to t power 3 minus 14t. Find an expression for its velocity at time t. So you can see that s is in terms of t. So means from this equation you know that when t change, s will change. Okay, so you need to find the relationship that let's see, because the question only ask you to find the velocity, you know that v equal to ds dt. So you can directly differentiate this equation and you will get a 3t square minus 14. Okay, so for this is your expression for the velocity, right? So the requirement of the question. But if you go further, this is not in your question. If you go further, the acceleration will be equal to 60, right? So the acceleration will be equal to 60 because you know the acceleration is equal to dv dt. Okay, so for in this situation you can see that when t change, okay, a will change. So this is not a constant acceleration case, so you cannot use the formula that provided in the chapter 1. So you need to do your own differentiation and integration in order to find the answer, right? Let's say, okay, let's say in this case, if you get a equal to 6, let's say, right, after you differentiate. So if this is the 6 that you get, this is a constant acceleration case. So if this happen, you can use the chapter 1 equation, right? If this did not happen, okay, the a can change, you must use differential integration only, yeah, right? So this is for question 1. Okay, question 2. A ball move in a straight line so that its displacement sm meter at time t is given by s equal to 2t power 3 minus 10t square. Find the speed when t equal to 2. So same things, s equal to 2t power 3 minus 10t square. Right. Question is asking you to find the speed when t equal to 2. So same things, v equal to 60, differentiate, minus 20t, right? So you have the v equation. So when t equals to 2, you have v equal to 6 times 4, 24 minus 40, you have negative 16. Right. So this negative 16 meter per second is a velocity, right? But the question asks you to find the speed, right? Then you know that the difference between velocity and speed is the direction. So for this question, you should put the speed is equal to only the magnitude, only the magnitude, right? So this is for question 2. Be careful about this because the speed and velocity are a little different. If you put the negative, then they may have a right to penalty your marks. Okay, they will penalize your marks based on the negative positive, right? Be careful about it. Okay, we'll move to question 3. Question 3. A particle moves forwards and backwards along a straight line so that its displacement as meters from the initial position at time t seconds is given by s equals to 2t power 3 minus 12t square plus 18t. Find the distance that is traveled in the first 5 seconds. Okay, so the s that given in your equation, the s that given in your equation, s equals to 3 power 3 minus 12t square plus 18t, right? This is a displacement equation. So from this equation, be careful a bit because the question is asking you to find the distance. The distance means you need to plus all the positive and negative displacement together. Okay, without the positive negative, only the magnitude. But the given equation is a displacement equation, and this is as you know, is a power of 3, is a cube, and you will know that this will cut through the positive and negative region, right? So this will cut through the positive and negative region from 0 to 3. You can check by using calculator, right? So in this situation, you need to verify when the particles, okay, when the particles, okay, or let's say originally move in a positive direction, when the particle will turn back to the negative direction and again turn back to the positive direction. You need to verify the turning point, right? If not, then you cannot justify where to use the positive displacement. Okay, only the magnitude. If you just sub the t equal to 5 inside, that one is the last displacement, right? But it's not the total distance. So be careful about this. So in this question, let's say if you sub t equal to 5 inside, you may get 250, okay, minus 300 plus 90, you get 40. Okay, 40 meter. This 40 meter is the last displacement at t equal to 5, but this cannot represent the total distance that travel. Okay, so now you need to verify where is the turning point first. Okay, you may have another methods. You may use the graph to find, but I will show you the calculus way. But if you want to use graph, no issue. You can visualize. It's okay for you also, no issue. Okay, and once you have this total displacement at the t equal to 5, now we're going to find the turning point. Okay, so when turning point, you know that when turning v will be equal to 0. So we find v first. V will be 6t squared minus 24t plus 18. Okay, so you know that when the particles turn the direction, v equal to 0. So when v equals 0, 6t squared minus 24t plus 18 will be equal to 0. And if you factorize, you will get equal to 0. Okay, so you will find t equal to 1 and t equal to 3. T equals to 1 and t equals to 3. Okay, in this situation, okay, you know the particle change direction at t equals to 1 and t equals to 3. So now we're going to check the displacement at t equals to 1 and t equals to 3. Okay. So the displacement when t equals to 1 will be equal to 12 minus 2 minus 12 plus 18. Okay, so you have 18. 2 minus 12 plus 8, sorry, plus 18. Okay. So I remove this part wrong. Okay, here will be 8. Okay. And the displacement when at the t equal to 3, you have 54 minus 108, 54 minus 108 plus 54 again, and you get t equal to, you get s equal to 0. Alright, s equal to 0 at t equal 3. So what happened in this situation? Okay, so I will draw the diagram for you roughly like that. So means the particle at t equal to 0, this particle move in this direction. Okay, 0 t. Okay, so and t equal to 1 is the turning point, t equals to 1. So this item turn back, and t equal to 3, this is t equal to 3, move to the original direction, position. And t equal to 3 also a turning point. So when t equal to 5, this one is 40 meter. Okay, so this is 8, this is 8, right? So from the diagram, the total displacement, total distance will be 8 plus 8 plus 40. So total displacement, total distance is 56 meter, right? So this is the way for you to calculate, right? So this is for question 3. Okay. Okay, continue with the explanation just now. You know that A will be equal to dv dt just now, okay, from the beginning, and so that is a second derivative of the s. Okay, this one I think you should learn before lah, right? Okay, the relation between A, S, and V. Okay, we move to question 4. Okay, question 4. A particle move in the straight line so that its velocity v at the time t is given by v equals to t squared. And find the expression for acceleration. So a will be equal to dv dt, and so that you know that is equal to 2t minus 4. Okay, a is equal to 2t minus 4 for question 4, right?